Welcome to all. Myself Dr. Vishwanath, Department of ENC, Rajiv Institute of Technology, Hassan. In this video demonstration, how to design and simulate a common source amplifier in multi-sim. Let's go to the introduction. So, common source amplifier. A common source, either JFET or MOSFET amplifier frequency response is characterized by its gain, that is either voltage or current, consider voltage or current, varying with the frequency. The frequency response is typically divided into three regions: low, mid, and high frequency regions. The low frequency response is mainly influenced by the coupling and bypass capacitor, and the high frequency response is affected by the parasitic capacitance within the MOSFETs or JFET and a Miller capacitance. And the mid frequencies is the region where the capacitor have minimal effect and the gain is primarily determined by the transistor characterized and biasing registers. So this is the circuit of the common source JFET amplifier. And the one advantages of this this JFET amplifier, see a common source JFET amplifier compared with the common emitter BJT amplifier, in that so FET has extremely high input impedance and along with the low noise output, and this make them ideal for use an amplifier circuit that require very small input voltage signals. This is very small VGS signal, input signals. And the expected frequency response plot already we discussed the low frequency, mid frequency, and high frequency. So due to this is also we discussed due to the input or output coupling capacitors with a high reactance at low frequency and midband gain, so determined by the minus transconductance into output that's RD, and the high frequency due to the parasitic capacitance. So some steps we follow to designing and plotting the frequency response in multi-sim. Okay, so the first one is how to circuit design. So first we select the JFET or MOSFET from the multi-sim library. I will showing in during the demonstration time, and choose the voltage divider biasing network for the gate. So that is select the R1 and R2 and supply voltage. So including the drain resistor, that is RD, and source resistor RS in the circuit. Add coupling capacitor C1, C2 and bypass capacitor CS, and all this connected the input signal to the gate and the output to the drain. So once the completion of the circuit design, then we need to select the simulation part. Okay, so simulation part we go for the AC sweep. So this is the practical circuit we are using. So in this circuit we are using the JFET BFW10 transistor and registers. So this is the registers I am using 1 mega ohm base register, and so next is a register. Okay, JFET transistor. Registers, load register, and coupling capacitor C1 and C2. So drain register RD is 2.7 kilo ohm I am using, and RS source register I am using 1 kilo ohm, and input signals connected to the gate of the JFET. So here we are using AC input signal, sine wave signals with a peak to peak amplitude. We can keep 1 volt, okay, peak to peak voltage with the 50 megahertz frequency. Change the frequency 50 megahertz. So just I will enter to the okay. So for amplifier, this is the already I constructed in multi-sim environment. Just I will show how to select the components, everything with a new design. So select the place and select the component, transistor, go to this transistor. So just you type here BFW10, okay, then place here, and after transistor, select the registers. Okay, register, go to the database, select component, basics, so registers. So totally registers we need how many in the circuit, just I will show here. Okay, just observe. So one is the register, base register with the 1 mega ohm, drain register, source registers, and load. So totally 4 register we need it in our circuit. So just you place that 1 mega ohm base register. Next, similarly, register. Later on also we can source, load, and the capacitors, coupling capacitors. Okay, later on we can change the values. Okay, and what you next you needed source. So source, sine wave, power source. Go to the power source, select AC power. Okay, place. Now after that, so we need supply voltage VDD. So VDD, go to component, place and component VDD. So VDD is 12 volt. Okay. Next, CRO, go to here, oscilloscope. You need oscilloscope. Okay, use it. Otherwise, not necessary for this one. Just rearrange the components. So the VDD values is 12 volt. Change, double click on this VDD and label, change the voltage value 12 volt. And what is the double click on drain resistance? You name it RD, drain, and the value is how much? Okay, 2.7 kilo ohm, and RS 1 kilo ohm, 1 mega ohm, 4 points, load is 4.7. So just I change 4.7. Okay, 1 ohm, RS is okay, and capacitor, coupling capacitor values is 0.001 microfarad, 0.001 microfarad. So after 0.001 microfarad, after editing all the component values, next is connection. So okay, sine wave signals, 1 volt AC, 1 volt peak to peak, 1 volt peak to peak. Oh, it is RMS. So one second, just AC voltage. You select signal AC voltage. Okay, component. So now you change here 1 volt, voltage peak is 1 volt, but frequency is how much? 50 mega. Megahertz. So now you need to connect these components. and one ground also you select. Go to the component, uh, ground. Okay, close the components library. Next, so connection. So after completion all the component connections, so we need to verify the output voltage. So select the junction. So place, so junction, the junction name is, give the junction name output. Double click on that junction wire, type output. So I change the okay. Now, so connection is completed. So this way we can connect it the circuit. The next is simulation part. Okay, simulation part. So once the completion of the connection, go to the AC sweep. So analysis and analysis and simulation. That is, go to simulated, select analysis and simulation. So here you can select AC sweep, and the frequency parameters are, so choose the frequency parameters. So here decade, vertical scale you selected decibel. Okay, save, and once again you double click AC sweep output. So output, here you can select the output, select add output, save, and run the. So observe the waveform. So this is the AC sweep, okay, AC sweep output, and similarly for the frequency response after this observation. So you can magnitude and phase you can observe in the graph. So close this. Just you double click on AC sweep. Once again you change here linear. So not here. Sweep type is decade, and vertical scale is linear. Run this one. One second. So just uh, change the AC sweep value, frequency parameter. Start frequency is 1 hertz, stop frequency is 10 gigahertz. 10 gigahertz. Yeah. You change the stop frequency is how much? 10 gigahertz. Sweep type is decade, and number of points per decade is 10. Vertical is linear. To see the waveform of the frequency, it's a common source frequency response. After that, varying the values, just save and run this program. So observe the graph. So observe the graph. The graph is the lower frequency, mid band frequency, and higher frequency. So to verify, to find the bandwidth, so select the for bandwidth, see. So you can give 1 point. So and the cursor. Okay. So this is your bandwidth. You got it. Okay. The distance of this is our bandwidth. The difference between the F2 minus F1. Okay, and so lower frequency, mid frequency, and higher frequency, and this is the bandwidth also you can find out by using this scale. Okay, find out the F2 value and F2 value and F1 value. Thank you.